be brave and take a guess. How do you find T1? This is not a giant stretch. Yes, go ahead. That's all you gotta do, right? So T1. Remember I said this is the easiest unit? Two, good. Oh boy. Okay, so T1 is equal to 2. T2 is going to be 3 bracket 2 minus 1 equals 6 minus 1, which is 5. T3 equals 3 bracket 3, and so on for T4. Again, if you think back to slope, this equation is like 3x minus 1. It has a slope of 3. And if you look at my y values, or what the term numbers are, 2, 5, 8, and 11, their first difference is 3, so it makes sense the equation shows a slope of 3. Good? Ready for more difficult? Okay. Just to bring you back into this course. Possible. I still have one person hasn't written. I could probably at least give you one of them back tomorrow. But I think the whole first test has been written, but the second test hasn't been. 0 so far. I haven't started it. Yours first. All right, Tn equals -4 to n minus 1. So I'd like you guys here to be careful with this. So take the next 30 seconds of your lives. Some of the values, make sure you get nice, nice answers. It's been a while since we've done exponents. Tiana, I'm picking on you. What's T1 going to equal, please? No. Hey, stop. Okay, so anything with a 0 is going to be 1, positive or negative. It works that way. All right. Taylor, what'd you get for T2?
-4, 2 minus 1.
Yeah.
-4 to 1.
Yeah, which is equal to? Good. Colton, what'd you get for T3, please?
T3 equals -4, 3 minus 1.
Okay, good.
-4 to 2.
Yeah. And it's positive, right? That's good. All right. Albert, T4, please.
I got -64, so -4
Yeah, I stapled everyone else's except for yours. Okay, so there it goes. There's the sequence. Now, this is the nice thing with these sequences. These are like general sequences we're dealing with here right now. Okay, where you're able to sub in any number. The nice thing about both these first two equations we've dealt with is that I can find, if I was looking for like T99, you could just sub in 99 here and 99 there and really get a value. Okay, our third type of sequence here we're going to talk about right now is called recursive sequences. These are sequences based on the previous. You will need a base case as a starting point. Okay, so the difference between a recursive sequence and sort of the standard sequences we've seen in the first two examples Or in a standard sequence, if I need to find the 99th term, I just plug n equals 99 into my equation, and there we go. For a recursive sequence, if I'm looking for the 99th term, that means I need to find the 98th term first, which means I need to find the 97th term before that, which means I need to find the 96th term before that, and so on and so on and so forth, okay? Recursive sequences are very difficult for human beings to process, but they're wonderful for computers. Just for a computer to do something simple 1,000 times, very, very easy. I don't know if anyone here is a computer programmer. I used to teach that here. Okay, but when you get to that sort of thing, it can be very, very powerful to solve things. Okay. Let's get into a nice example here, hopefully. Okay, example 2. Find the first 4 terms of each sequence. Okay. A is going to say T3 equals, or T1 is equal.
Where is the example 3?
What is? What is that? What? A1 says T1 equals 3, and Tn equals 4 Tn minus 1. Okay, now you'll see how this looks a lot different than what we dealt with before. Okay. Okay, so what I think you should try and do right now is just try and think of what that means. What do you think Tn equals 4 Tn minus 1 means? What do you think that actually means? Start on the left.
Equals 3.
What's that?
T1 equals 3.
Good. What does T1 equals 3 mean? What does T1 equals 3 mean? First term's 3. What does Tn equals 4 Tn minus 1 mean? Well, what does Tn minus, start with that, what does Tn minus 1 mean? Yeah?
The term before minus 1.
Yeah, not minus 1. Okay, this is going to be, if n is your, like let's say I do T10, that's going to be 4 times what? T9. Not T9 minus 1, just T9. Right, because the n matches the n, right? Right, so that, okay. So in general, what this means is Tn equals 4 times the previous term. Okay. Now the reason that we need to have a starting point here, okay, is because if I were to use the equation for T1 equals 4 times T0, you never have a T0. T1 is where it always starts. Okay? So to write it, I just made it up just to sort of see it prove the point here. Okay? So this we don't actually need, I can get rid of that, okay? So if I start at T1, T1 is equal to 3, okay, because this was given. Okay, so how do I get T2? What's T2 going to equal here? Please someone be brave. 3 times 4, okay? So I'm going to write it as, I'm going to write it formally here first, but you're exactly right. Okay, now this is a time that you ask questions if you're not sure about what I just did there, right? Because n minus 1 means whatever the subscript is for the outside term, you're going to just subtract 1 and turn it 1 less. Okay, good. So, oh, sorry, Tiana's got a question or a stretch or a...
No, I'm just...
Oh, okay. So what? Good question. No, it's fine. This says 4. Okay, good question. So it says T2 equals 4 times T1. T1 is just 3. Right, because this is like our given. That's like our base case. That's like our starting value. You need something to start with on these because you don't like that's just like a. Okay, because when we break, what's T? Sorry, go ahead. No, it's not a subscript. Like the one, always these little like. Think of Tn like f of x. It's the same thing, right? Where what this is just going to be like you're subbing in like the value of the term at number one, right? The value of right, so this is the value of the term on this side of the second term. Okay, can somebody brave and give me what T3 is going to be, please? Georgia, go. Georgia, go. Georgia, you know. Good. Very good. So I heard someone say 12 times 4. Where we got that from successfully was when you're talking about T3, when we're talking about T3, it's going to be one less than that. Okay, so T3 is 4 times the one before it. T4 then finally is going to be 4 times T3. Is, what is that, 192? There's the first 4 terms. Let's pick one slightly more complicated, because that's one that's just, you could do without that. There's another we could remove. Here, I want you guys to try this one for me right now, if you would be so brave. B. All right, T1 equals -2. T2 equals 3. Tn equals 2, Tn minus 2, plus 3, Tn minus 1, plus 1. Okay, if Tn minus 1 means the term before it, what does Tn minus 2 mean then? Okay, right, so let's say we want, like, the way I'd write this, and I'm not going to be able to keep it in your notes, if I wanted to find, like, T10, this would be 2 times T8 plus 3 times T9 plus 1, right? So if n is 10, n minus 1 is going to be 9, right? N minus 2 is going to be 8. But we're not using those big numbers, okay? What you are doing is you're going to hopefully solve that for 1, 2, 3, and 4, and that would be lovely. You don't mind me saying lovely.